Good morning, children.
Morning, ma'am.
Morning, ma'am.
How are you all?
Fine.
Fine. Happy, right? Yes. So, what all things we have learned in the last class, children?
And we just discussed the exercise questions.
Okay. Of the second chapter, right? Yes. So today we are going to learn a new chapter. Okay, a new chapter, chapter 3, atoms and molecules. Okay, chapter 3, atoms and molecules. Okay, Adlio, can you tell me anything about this atom and molecule? What all things you know about atom and molecule?
An atom is a basic.
Yeah, basic unit of
unit of matter.
which one? Basic unit of
Particles.
okay, particles, matter, etc. Then what about molecule, Adlio? Molecule. We have learned it in the last chapter, right? Molecule, how these molecules are formed. Okay, Advait, you can tell me what all things you know about atoms and molecules. How these molecules are formed.
Ma'am,
Yeah, Nandana.
ma'am, it's a group of atoms.
Yeah, it's a group of atoms or a combination of atoms, right? Okay, so in this chapter, we will learn about this atoms, molecules, then different theories based on this atoms and molecules. There are certain laws. Okay, so are you ready to learn, children? Tell me, are you ready to learn?
Yes, ma'am.
That's
Yes.
right.
Okay. So you can write down the heading chapter 3, atoms and molecules. Atoms and molecules. Chapter 3, atoms and molecules. So we will start this chapter from its history onwards. Okay. We will start this chapter from its history onwards. How these atoms were discovered or how these molecules came into exist. So this is considered as the beginning of this discovery or studies about atom. Okay. Around 500 BC. 500 BC. What's the full form of BC?
Before Christ.
Before Christ.
Okay, it's before Christ. So around 500 BC, Indian philosopher Maharishi Kanad. That's the name of a philosopher, Indian philosopher Maharishi Kanad. He postulated means he suggested or he introduced the theory. If we go on dividing the matter or padarth, okay, in Sanskrit, we will use this word padarth. Okay, if we go on dividing the matter or padarth, we will obtain smallest particle beyond which further division can't be possible, which is known as paramanu. Okay, if we go on dividing this matter or padarth, we will obtain smallest particle beyond which further division can't be possible. So it is considered as the smallest particle. Okay, and this smallest particle, it is known as paramanu. Here, children, paramanu. Okay, if we go on dividing this padarth, paramanu will be obtained. It's the smallest particle. Further division can't be possible. Okay, clear? This is clear about the first point?
Yes,
Yes,
ma'am.
Okay, around 500 BC, Indian philosopher Maharishi Kanad, he postulated the theory, if we go on dividing the matter or padarth, we will obtain smallest particle beyond which further division can't be possible. It is known as paramanu. Okay, then two ancient Greek philosophers, Democritus and Leucippus. Ancient Greek philosophers, Democritus and Leucippus, they call these particles atoms. Indian philosopher named the smallest particle as paramanu, and later ancient Greek philosophers, they will name the smallest particles as atoms. Okay, Then this Antoine L. Lavoisier. That's the name of the scientist. Okay, Antoine L. Lavoisier. Can you repeat? Antoine Antoine L. Lavoisier. Once again. Yeah, Antoine L. Lavoisier. He laid the foundation of chemical sciences by establishing two important laws of chemical combination. So he introduced two laws. Okay, two laws of chemical combination. It is considered as the foundation of chemical sciences. Clear, children? So this is considered as the beginning or history of the discovery of these atoms and molecules. In around 500 BC, Indian philosopher Maharishi Kanad, he postulated the theory, if we go on dividing this matter, the smallest particle will be obtained and further division can't be possible. And that smallest particle, it is known as Paramanu. The later ancient Greek philosophers Democritus and Leucippus, they call these particles as atoms. Okay. Then Antoine L. Lavoisier, he laid the foundation of chemical sciences by establishing two important laws of chemical combination. So in the beginning itself, we are going to learn two important laws that comes under laws of chemical combination. Clear? Have we completed these points?
1 minute.
Okay. So Pooja, can you please read the points?
Yes, ma'am. Around 500 BC, Indian philosopher Maharishi Kanad postulated the theory, if we go on a dividing matter, Padarth, we will obtain smallest particle beyond which further division cannot be possible, which is known as Paramanu. Ancient Greek philosophers Democritus and Leucippus call these particles atoms.
Okay.
Antoine L. Lavoisier laid the foundation of chemical sciences by establishing two important laws of chemical combination.
Okay. Have we completed, children?
No, ma'am.
Okay, okay. You can take your own time. You have to always remember the name of this scientist, okay? Antoine L. Lavoisier. And this one, laws of chemical combination. There are two laws comes under this, laws of chemical combination. Finished?
Yes, ma'am.
All of you? Helen, have you completed?
Yes, ma'am.
Okay. Ken, Jairus, Anashwara, Advaid, Nivedya, Fadil, Hritvik, Adleo, Tamanna, Ausan, Suryadev, Nadeem, Albert, Abiram. All of you switch on your videos. Then we are moving to the next topic, that is laws of chemical combination. Okay, laws of chemical combination. So here, there were two scientists. They established these laws after several experiments. And this name of scientists, one is again Antoine and Lavoisier, and the second one, that is Joseph L. Proust. Okay, these laws established after the experiments by Lavoisier and Joseph L. Proust. Clear, children? These laws were established after the experiments that conducted by Lavoisier and Joseph L. Proust. Okay, then the chemical reaction between two or more substances. We know that two, if A is one reactant, then B is another reactant. The substance that undergoes reaction, it is known as reactant. Okay, and the new substance obtained, that is product. Clear, children? The substance that undergoes a chemical reaction, it is known as reactant. Okay. Then the new substance obtained, that is known as product. If hydrogen and oxygen reacts together to form water, which are the reactants, sir? Lynette? Lynette, can you hear me? Network issue there, right? Isha, can you tell me? When hydrogen and oxygen reacts together to form water, which are the reactants?
Hydrogen and oxygen.
Very good. Hydrogen and oxygen. Because this hydrogen and oxygen, they undergoes a chemical reaction, right? Okay. Then what about the product formed in the above reaction? Anandita?
Yes, ma'am.
In this reaction, hydrogen and oxygen combines with water, combines to form water. Okay. Which is the product there? Product means the new substance formed. Not possible to unmute? Try once again.
Yes, ma'am.
Okay, tell me. Which is the product there? Yeah. Technical issues there. It's okay. Tom, can you tell me which is the product?
Water.
Yeah, water. Okay, so you have to remember the substance that undergoes a chemical reaction, it is known as reactant, and the substance, the new substance form, that is known as product. Okay, product. So, this laws of chemical combination, these are certain laws that governs the chemical reactions. The chemical reactions between two or more substances give rise to products. It is governed by certain laws. These laws are known as laws of chemical combination. So A plus B giving AB. These two are considered as reactants. And AB is the product. AB is the product. The chemical reaction between two or more substances give rise to products, which is governed by certain laws called laws of chemical combination. Okay, these laws established after the experiments by Lavoisier and Joseph L. Proust. Then the chemical reaction between two or more substances give rise to products, which is governed by certain laws called laws of chemical combination. Full name, here it is Antoine L. Lavoisier. Okay, Antoine L. Lavoisier. The name of the another scientist, that is Joseph L. Proust. You have to remember the names of these two scientists. They are behind this laws of chemical combination. Henin, can you please read the points?
Ma'am, I can't see the screen share.
Why?
I
Just
think
wait. Just wait. What about now, Henin?
yes, ma'am.
Okay, then you read.
Laws of chemical combinations. These laws established after the experiments by Lavoisier and Joseph L. Proust. Chemical reaction between two or more substances give rise to products which are governed by certain laws called laws of chemical combinations.
Okay, laws of chemical combination. Have we completed, children? All of you? Have we completed these points?
Yes, ma'am.
All of you, right? Okay. Then there are two laws comes under this laws of chemical combination. Okay. First one is law of conservation of mass. First law is known as law of conservation of mass. Okay. Amaljit, can you please mute?
Sorry, ma'am.
It's okay. Okay. Law of conservation of mass. What's the meaning of this term? Conservation. Conservation. Yeah, Lynette?
Conserving the mass.
Yeah. Preserving or conserving the mass, right? Or protecting the mass. So the same thing is explained in this law. During a chemical reaction, you know that certain reactants that undergoes a chemical reaction or a chemical change, then a new product is formed, right? So throughout this reaction, the mass of this reactants and products, it will be conserved. That means the mass of the reactants and mass of the product, it will remain same throughout the reaction. Can you tell me any chemical change? Example for one chemical change.
Rusting.
Digestion.
Okay, digestion of food, then another.
Rusting.
Burning of paper.
Yeah, burning of paper. Okay, when you think about that burning of paper, it's an example for chemical change. So definitely a chemical reaction will take place there, right? Yes. So the what will be the product obtained on burning of this paper?
Ash.
Ashes, right? So the amount of paper that will get burned, that will be equal to the amount of ash obtained. Okay, that means the mass will remain constant during the reaction. No new mass is added or no mass is destroyed during a reaction. Okay, that is law of conservation of mass. That is the first law that comes under laws of chemical combination. So shall I move to the slide, children?
Yes, ma'am.
Okay. So law of conservation of mass. During a chemical reaction, the total mass of reactants will be equal to the total mass of the products. Okay, during a chemical reaction, the total mass of the reactants will be equal to the total mass of the products. And the main statement of this law of conservation of mass, it states that mass can neither be created nor destroyed in a chemical reaction. That's the statement of this law. Okay, in the question paper, when you see that state law of conservation of mass, you should write this one. Okay, others are certain explanation for this law. This is the accurate statement of this law. Mass can neither be created nor destroyed in a chemical reaction. That means no new mass is added or no mass is destroyed during a chemical reaction. Always it remain constant. So during a chemical reaction, the total mass of reactants that will be equal to the total mass of products. So the statement of this law, mass can neither be created nor destroyed in a chemical reaction. And you can also write this example. A plus B, both are reactants. It will give the product AB. So mass of A plus mass of B, that will be equal to mass of AB. Okay, and in this figure also, you can clearly see that amount of firewood it burns, that is equal to the amount of ash obtained. So the mass will always remain constant, mass, during a chemical reaction. That is the first law of conservation of mass. Sridev, can you please read the slide?
Law of conservation of mass.
Okay.
During a chemical reaction, the total mass of reactants will be equal to the total mass of the products.
Okay.
Law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction.
Okay.
Example A. It is a reactant plus B. Another reactant gives AB, which is the product.
Okay.
Mass of A plus mass of B equal to mass of AB.
Okay. This is clear, children?
Yes, ma'am.
Yes,
Okay.
ma'am.
Have we completed the points about law of conservation of mass?
Yes, ma'am.
All of you?
Yes, ma'am.
No. Okay. Okay. Fadil, completed?
ma'am.
Okay. Then there is another law, that is law of constant proportion or law of definite proportion. That's the second law that comes under laws of chemical combination. Before learning this law, we should know certain things. So after this law of conservation of mass, Lavoisier and certain other scientists, okay, Lavoisier along with other scientists, they noted that, okay, they noted that many compounds were composed of same elements. Many compounds, they were composed of same elements. That means one or more elements. They can be combined in a same ratio. Okay, they can be combined in a same ratio, irrespective of where the compound is obtained. Consider the example of water. Water is an example for a compound, right? Water is an example for a compound. Which are the elements present in water?
Hydrogen and oxygen.
Yes, hydrogen and oxygen, right? So when you take some water from well or from river or from pond or from anywhere from any country, always the ratio of this hydrogen and oxygen, it will always remain constant. Okay, it will always remain constant. What's the chemical formula of this water? Can you tell me, children?
H2.
Yeah, it's H2O, right? H2O. That means 2 hydrogen and 1 oxygen, isn't it?
Yes,
Means the ratio is 2:1. So in the case of this compound, it's made up of more than one element. That means 2 different elements are there. They are combined together in same proportion or same ratio, irrespective of where the compound came from or who prepared it. All the water molecules, they have a general formula H2O. And the elements in this compound, the ratio between these elements, it will always remain constant. In the case of water, it is always 2:1. That's the ratio of hydrogen to oxygen. If we take some water from India or from any other country, always the ratio between this hydrogen and oxygen, it is 2:1. Okay, so these discovery or these experiments, they later lead to the discovery of second law, law of constant proportion or law of definite proportion. So you can note these point also. Lavoisier along with other scientists noted that many compounds were composed of 2 or more elements, and each such compounds have the same elements in the same proportions, irrespective of where the compound came from or who prepared it. If you prepare the same water in laboratory, it's also have the same proportion or same ratio, that is 2:1. Not only in the case of water molecule, all other compounds, they are made up of the same elements. They have a constant proportion or a constant ratio. Have you completed, children?
Yes, ma'am.
All of you? This is clear for you about law of conservation of mass and this ratio between the elements of compounds.
Yes, ma'am.
Okay,
Ma'am.
then just 1 minute. Let me take your attendance. So we already learned one law that comes under laws of chemical combination. What's the name of that law, Alan? First law that comes under laws of chemical combination. Alan?
Yes, ma'am.
Yeah. Which is the law that comes under laws of chemical combination?
Law of conservation of mass states.
Yeah, law of conservation of mass. Okay. Then what about the statement of this law of conservation of mass? Adhikesh? Hmm.
During a chemical reaction, the total
Statement of
mass
law. Statement of law.
law of conservation of mass states that mass can neither be created or destroyed in the chemical reaction.
Mass can neither be created nor destroyed in a chemical reaction. What's the meaning of this law? Law of conservation of mass. Isha?
Conserving.
Can you repeat?
What's the meaning or how can you describe this law of conservation of mass?
Ma'am, law of conservation of mass states that the total mass of the product formed is the sum of the total mass of its reactants.
Okay, that's the explanation for this law of conservation of mass. Okay, then after this law of conservation of mass, I told you Lavoisier along with other scientists, they noted that many compounds were composed of 2 or more elements. They are always remain in a same proportion or fixed ratio irrespective of where the compound came from or who prepared it. Okay, this led to the discovery of law of constant proportion. Law of constant proportion. It is otherwise known as law of definite proportion. Law of constant proportion or the other name is law of definite proportion. Law of definite proportion. So the statement of the second law, law of constant proportion, in a chemical substance, the elements are always present in definite proportions by mass. Okay, their mass will always remain in a constant proportion or a constant ratio. In a chemical substance, the elements are always present in definite proportions by mass. And it was given by Proust. It was given by Proust. So this law of constant proportion, it was proposed by Joseph L. Proust. In a chemical substance, the elements are always present in definite proportions by mass. Definite proportions by mass. This is the second law that comes under laws of chemical combination, law of constant proportion. Lakshmi CV, can you please read the statement of this law?
Yes, ma'am. Laws of constant proportions.
Law of
A law of constant proportion, otherwise known as laws of definite proportions.
Law of.
Sorry, ma'am.
Yeah.
In a chemical substance, the elements are always present in definite proportion by mass. It was given by Proust.
Proust. Joseph L. Proust. Have you completed this slide?
Yes, ma'am.
All of you? Yes, okay. Then we can just look at one example. The same thing, H2O. Okay, I told you 2 hydrogen and 1 oxygen atom there. The mass of 1 gram, 1 oxygen atom, that is 16. Okay, 16. That's the mass of oxygen that you will learn in the next chapters. Okay, there is a fixed mass for each element in a periodic table. So in the case of oxygen, it is 16. So you have to remember it. Okay, and in the case of hydrogen, it is 1. Oxygen, it is 16. So here there are 2 hydrogen atoms. So 2 gram of hydrogen, then only 1 oxygen atom plus 16 gram of oxygen. Okay. Then the mass of hydrogen by mass of oxygen, that is 2 by 16. 2 by 16, that is 1 by 8. 1 by 8. That's the actual ratio between their mass. I told you 1:2. That's the ratio between the elements present in that compound. Okay. But here we are specifically given importance to mass. So you have to remember the mass of hydrogen atom, it is 1. Then mass of oxygen atom, it is 16. Here there are 2 hydrogen atoms. So 2 into 1, that is 2 gram of hydrogen. The next one, in the case of oxygen, it is 16 gram of oxygen. Only 1 oxygen atom, so 16 gram. So when you look at the ratio between mass of hydrogen and mass of oxygen, it is 2 by 16 and it is 1:8. That's the ratio. Okay, that is for 18 gram of water. When you add these 2 masses, you will get 18, right? 18 gram of water will be obtained. So through this example, you can state 2 laws. The law of conservation of mass also stated here, because 18 gram of product is obtained. When you add the reactant's mass also, it will be obtained 18. That means mass of the reactant remains constant throughout the reaction. Then in 36 gram of H2O, 36 gram of H2O, 4 gram of hydrogen. That means 4 hydrogen atoms are there. Okay, 4 hydrogen atoms are there. Then 32 gram of oxygen. That means 2 water molecules. Okay, H2O and another H2O. So the sum total 4 gram of hydrogen plus 32 gram of oxygen. When you take the ratio between these two, the same ratio will be obtained, 1 by 8 or 1:8. Then the third example, that is 9 gram of H2O. 9 gram of H2O. Here also 1 gram of hydrogen, then 8 gram of oxygen. That's a half portion, half molecule of water that is considered as this 9 gram of H2O. So 1 gram of hydrogen and 8 gram of oxygen. When you take the ratio between these two, the same, 1 by 8 is obtained. So it states that this verifies the law of constant proportion, as the ratio of mass of hydrogen to oxygen is always same. Okay. So this is a proof for the second and first law. First law also stated here, because when you look at the mass of product and reactant, it will remain same, right? 18 gram of H2O. When you add 2 plus 16, it's also 18. That means the mass remains constant throughout a reaction. Okay. Have you completed this one, children? All of you?
Yes, ma'am.
Finished, right? Okay. So today we learned 2 laws that comes under laws of chemical combination. First one is law of conservation of mass and second one is law of definite proportion. Okay, this is clear? Tell me, yes or no?
Yes, ma'am.
Yes,
Okay.
ma'am.
Okay, then we can discuss the remaining things in the next class. Okay. Okay, then thank you all. See you in the next class. Bye.
Thank
Thank
you.
you, ma'am.
Thank you.